Hey guys, this is going to be an intro to college algebra, and we actually won't start until next Wednesday, which will be the January 15th. But what I'd like to do is I'd like to have you guys do some practice problems beforehand, because once we get started, college algebra really is like Algebra 2, but it's like jumped into one semester rather than a full year. And so some of the concepts that we're going to go through will be somewhat easy, because you're going to feel like, wow, this is Algebra 1 stuff. But then we get pretty in-depth pretty quickly. So what I wanted to do for this week is just give you guys some background. I'll give you some credit for this. This will be part of your homework or extra problems that we do. But after you finish this, I'd like to go ahead and have you just take a picture of it, or have your facilitator scan it to me, and then I'll give you some points for getting this done. So let me jump right into this. Now, first of all, this worksheet is actually in your classroom, and I did go ahead and add you to my college algebra classroom and Google Classroom under the SkyCan. If you have any problems at all, will you please go ahead and just reach out to me, and I will try and make sure we get that adjusted, because I do know that I did type in someone's name wrong just in the class I had before. So I know it can happen, and so just let me know if it's wrong. Also, you will notice there is that information sheet that I had you do last semester. I know you did it. It's the same questions, but I thought, you know what, I want you to give me a little bit of feedback on maybe some ways that I can maybe make this class a little bit better for you, and from what we learned from last semester. So you can get that done, and I'd like it due maybe at the first of the next week. Let's jump into factoring. Now, I'm going to say this, there's going to be a lot of F word. This is the F word in Algebra 2, and it's not the F word that you think of. It's factoring. We do so much factoring in algebra and college algebra that you really need to have a good basis for it. And so what I'm going to start off with is just the difference of two squares. Now, the first one is actually number 2. A lot of times your textbooks will start off with factoring a squared minus b squared. And it factors to two conjugates. And conjugates just mean the same parentheses, but the sign in between is changed. So in other words, when I factor the square, a squared minus b squared, it's the difference of two squares. And so I want to take the square root of both. The square root of a squared would be just a. The square root of b squared would be b, and then the next one would be also ab, and the signs in between have to be different. So one has to be a positive and one has to be a negative. And again, you can write them in either order. So it could be a plus b times a minus b, and it'd be just the same. Now, the reason behind that is, if you remember before, when we multiplied these out in modern college algebra, what we did is we started off with, we multiplied the first terms together was a times a, which would be a squared. And then in the middle, my O and I term of FOIL would be then, my inner terms would be a negative b times a, or let's go ab. And then I'm going to have my outer terms, which would be a times b, so it's going to be plus ab. And then the last one would be a minus b times a positive b, which would be minus b squared. Every time you multiply conjugates together, the middle terms will always cancel out. And so that means then you'll end up with a squared minus b squared. So today we're going to be just working on factoring. Now, factoring, we're going to work on expressions. Now, expression is just something without an equal sign, okay? So we're not solving at this point, but we're going to show you what the difference is a little later. So when I do factor this, I'm going to start off with, I'm going to take the square root of both. And so I'm going to have the w, and then I'm going to have w. I'm going to take the square root of 4, which is going to be 2 and 2, and then I'm just going to have a plus and a minus in between. And so w squared minus 4 is the difference of two squares, and it factors to w plus 2 times w minus 2. Now, again, I could have different numbers in here, so I'm going to jump down. Let's just go ahead and do like this one. Where again, if I have the square root of 25, x squared minus 36, I should recognize that both of these are going to be perfect squares. And so when I factor it, then my first term is going to be the square root of 25x squared, which is be 5x. And then I'm going to have the square root of 36, which would be 6. So I'm going to go 5x and 6 again. And then remember, I can either go plus or minus, and I just have to make sure they're alternating. So I'll go minus this time and then a plus. I'd like you to go ahead and just finish this worksheet out, okay? If you flip over to the next page, it's the same type of problem. This one is still the difference of two squares. Okay, but it kind of pulls in a different twist. Okay, so again, remember when you take the square root of 4/9, the square root of 4/9 would be 2/3, and so that's going to be your first term. But look at this next one. One of the rules for factoring is always look to see if I can pull something out first. And if you notice, like I could pull out a v on both of them, but also the 27 is not a perfect square, and neither is 12, but they have a common factor of 3. So in other words, I need to factor out a 3v before I even start to look for my difference of two squares. So if I factor out a 3v, then I end up with then 9. I'm going to have then u squared. Then I'm going to have minus 4v squared. And then now this is going to be my difference of two squares. So my factored form would be 3v times the square root of 9u squared would be 3u. And then I have 2v. And then I'm going to also go 3u, 2v. But then I need to change it, put the signs in between, would be a positive and then a negative. So I'd like you to check, to do the rest of these. They're super simple. I want you just to do them in class. I know it shouldn't take you long. It should not be homework for you. All right, the next one is just a practice on factoring trinomials. Now, when I introduced this, and I did it the same in modern and in our modern college math last time too, is I started off with the trinomial x squared, and I'm going to start off with plus 5x plus 6. Okay, and I'm going to factor that. Now, what I'm going to do is I'm going to show you also if I have x squared, I have minus 5x plus 6. Factor then x squared. I'm going to go plus 5x minus 6. And then I'm going to go the last one, x squared minus 5x minus 6. Now notice, they're all the same type, almost the same trinomial. The only difference is going to be the sign in between. But the first two right here, these are going to be what we'll talk about when we add the factors. So you always looked at first at the last term. If it's going to be positive, in this case, you know you're going to say factors of 6 that add up to 5. Well, luckily 6 has only a couple factors. The factors of 6, wow, I'm getting all choked up. Factors of 6 would be 1 and 6 and also 2 and 3. And so the reason I'm going to pick this one is on the add, I'm looking for something that's going to add up to the factors of 6 that add up to 5. And in this case, it's going to be the 2 and 3 because 6 plus 1 would be 7. And then when I do my parentheses, I know I'm going to go x and x. I'm also going to have factors of 2 and 3. In this case, if I'm adding the factors, it'll always be the same sign. Okay, it's either both signs will be positive or both of them are negative, and this is the one that tells you what they both are. So in this case, I have both positive, and so this factors to x plus 2 times x plus 3. Now look at the same one. I still have factors of 6 that add up to 5, but this time they're negative. So again, I'm still going to look at 2 and 3, so I'm going to have x and 2 and x and 3. And remember, I could go 3 and 2. It doesn't matter. It could be in any order. But this is going to tell me that both of my factors are negative. So I have x minus 2 and x minus 3, or I can go x minus 3 times x minus 2. But remember, anytime that the sign in front of your last constant term is positive, you're adding the factors. And both those signs will be the same. Now notice I changed it on this one. So the next one is going to be factors of 6 that subtract to give me 5. Well, in this case, 3 minus 2 is going to be 1, so I know that's not the case. So I know that I'm going to have to go with 6 and 1. So 6 minus 1 is going to be 5. So in other words, this is going to be x and 1 and x and 6. And then this sign will tell me that the largest factor has to be the same sign as my middle term. So I want to have a positive 6 and a negative 1. The second one is a similar, so I'm going to go factors of 6 that subtract to give me a negative 5. And in this case, the only thing that will change is going to be my sign. So I'm going to have x and I'll have 1 and x and 6. But this time my negative has to go with the 6 and a positive will go with the 1. So that's a kind of a quick review. So try these out. Try and get the rest of these, the problems that they're in at the end. all of my problems that I'm giving you today are going to be ones that have a coefficient, the leading coefficient of 1. In other words, right here it's 1. And so we're going to work on when they get a little harder tomorrow. So I hope you guys are having I hope you had a great Christmas. I hope you had are you ready to get started with some college algebra and have some fun? And remember, we're going to do a lot of factoring, and that's the F word that we're going to end with today. Thanks.